This lesson is the first part of graphing motion. We're going to be focusing on two types of motion: constant non-zero velocity and constant non-zero acceleration. Non-zero just means that there actually is some velocity and there actually is some acceleration. First, let's take a look at an example of an object moving with constant velocity. This man is moving across the screen at 1 meter per second the entire time. Now let's take a look at how much distance he covers each second. As you can see, each second he traveled 1 meter. We could also look at this on a graph. If he traveled slower, the graph might look like this. If he traveled faster, it could look like this. And if he was traveling to the left instead of to the right, the graph might look like this. Ultimately, what we find is that the relationship between displacement and time for an object moving with constant velocity is a linear relationship. Now let's take a look at the velocity versus time graph for an object moving with constant velocity. I don't think you should be surprised by this result. He's moving at a constant velocity of 1 second, and that's exactly what the graph shows. He could have been moving faster than this or slower than this. He could have been moving in the negative direction. But no matter what, at a constant velocity, we can see that the velocity doesn't change. It's constant. Now let's take a look at constant acceleration. This man is moving across the screen with an acceleration of 1 meter per second squared. Once again, let's take a look at the distance he covers each second. Since he's moving faster and faster each second, he covers more distance in later seconds than in earlier seconds. We'll also take a look at this on a graph. If he was moving forward but slowing down, the graph might look like this. If he was moving to the left and slowing down, it would look like this. If he was moving to the left and speeding up, it could look like this. No matter what, for an object moving with constant acceleration, the displacement versus time graph will be exponential. Let's look at the velocity versus time graph for constant acceleration. Each second, his velocity increases by 1 meter per second. If he was moving to the right but slowing down, his graph could look like this. If he was moving to the left and slowing down, the velocity graph would look like this. And if he was moving to the left and speeding up, it could look like this. No matter what, though, the relationship between velocity and time for an object moving with constant acceleration is linear. Let's summarize. For constant non-zero velocity, displacement versus time will always show a linear relationship, and a velocity versus time graph will show that the velocity is constant. For constant non-zero acceleration, the displacement versus time graph will always show an exponential relationship, and the velocity versus time graph will always show a linear relationship.